American self-taught mechanics Wilbur, born in 1867, and Orville, born in 1871, Wright became interested in aviation at the end of the 19th century. It was a time when technological progress was advancing in great leaps. Yet it seemed that one of humanity's boldest dreams, to build a machine capable of flight, was still far from reality. Experiments with steam-powered aircraft had all ended in failure. Alexander Fedorovich Mojaiski in Russia, Clément Ader in France, and Hiram Maxim in England, all of them were unsuccessful. The fate of the first glider pioneers was even more tragic. In 1896 in Germany, Otto Lilienthal crashed during a flight on his homemade glider, and 3 years later his English follower Percy Pilcher met the same fate. One of the few who continued experimenting with gliders at the end of the 19th century was the American engineer Octave Chanute. He improved Lilienthal's design, making it more practical. But most aviation enthusiasts had already turned their attention to airships and balloons. Fortunately, progress is built on the fact that individual failures cannot stop the development of a promising idea. And in the end, that idea prevails. It was precisely the death of Otto Lilienthal, or rather the newspaper reports about this tragedy, that sparked the Wright brothers' interest in aviation. After several years of intense work, this interest led to the creation of the first successful airplane. At first, Wilbur and Orville Wright, who lived in the small city of Dayton, Ohio, and worked as mechanics in their own bicycle workshop, simply read everything they could find about aviation. Then they spent long hours discussing what the flying machine of the future should be like, and how to avoid the mistakes of their predecessors. Finally, in the year 1900, the Wright brothers began designing flying machines. It must be said that at that time, their ambitions did not extend beyond mastering glider flight. The wing of their future glider was modeled after Octave Chanute's American biplane glider, but the similarities ended there. The Wright brothers' glider had no tail assembly, the pilot lay flat on the lower wing, and the control system was fundamentally different. Speaking at a meeting of the Western Society of Engineers in Chicago in 1901, Wilbur Wright explained these innovations as follows. After long consideration, we came to the conclusion that the tail assembly causes more problems than it solves, and therefore decided to abandon it completely. It seemed logical that if the pilot were positioned horizontally rather than vertically, as in the machines of Lilienthal, Pilcher, and Chanute, air resistance could be significantly reduced. Furthermore, Lilienthal's method of control, which relied on shifting the pilot's body, seemed to us insufficiently effective. Therefore, after much discussion, we devised a combination of two large surfaces, as in Chanute's glider, and a smaller surface placed slightly in front. The position of this forward surface is such that the force of the wind upon it counteracts the shifting of the pressure center on the main wings. As a result, changes in wind direction and speed have only a small disturbing effect, and the pilot merely needs to control the machine. This is achieved by curving the front surface upward or downward. However, the most important innovation in the aircraft's design, which Wilbur did not mention in his report, was the system of lateral control through wing warping, increasing the angle of attack at one wingtip while simultaneously decreasing it at the other created the control moment needed to correct rolls and maneuver in flight. This was the prototype of modern aileron control. The Wright brothers borrowed their method of controlling the glider from observing birds. My observations of the flight of buzzards led me to conclude that they restore lateral balance when a gust of wind disturbs it by twisting the ends of their wings. If the rear edge of the right wingtip twists upward and the left downward, the bird becomes like a living windmill and immediately begins to turn around the axis that runs from its head to its tail, Wilbur Wright wrote in his diary. Before applying this new control method to a glider, the Wright brothers tested it on a kite and were satisfied with how the wing warping system worked. The first glider built by the Wright brothers appeared in the summer of 1900. Its wingspan measured 17 feet and its weight was 48 pounds. The main material, as in all later Wright designs, was pine wood with a fabric covering. The wing with two spars had a special shape, strongly curved at the front and almost flat at the rear. The brothers believed this design would provide greater stability for the position of the center of pressure. The camber ratio was 1:23 of the chord length. The glider trials took place in the autumn of 1900 at the remote location of Kitty Hawk on the Atlantic coast. The soft, sandy ground and steady winds made it ideal for flight experiments. The machine, with a person on board, was to be launched on a tether like a kite. By using this testing method, the Wright brothers hoped to gain good flight control experience without putting themselves in danger. However, these plans did not come true. The lifting force of the wing turned out to be much lower than expected, and the wind strength was insufficient to raise a person into the air. Therefore, the glider was tested mostly without a pilot, controlled from the ground. Short manned flights were possible only during gliding descents from hills after a running start into the wind. Since the pilot lay on the wing and could not help with the takeoff run, two assistants had to accelerate the glider to the takeoff speed while holding its wings. Because of the insufficient lift, the total flight time achieved by the Wright brothers during the field season of 1900 amounted to only about 2 minutes. That was, of course, too little to make final conclusions about the flight characteristics or to gain the necessary piloting skills. Therefore, in 1901, the brothers built a new, larger glider. Its wing area measured 291 square feet, the wingspan 22 feet, and the weight 99 pounds. The camber ratio was increased to 1:12. The control system remained the same, except that the wing warping was now operated not by a lever, but by shifting a wooden cradle sideways with the pilot's hips while lying on the wing. The new glider tests began at Kitty Hawk in July 1901. This time the aircraft was tested only in free flight. As in the previous year's experiments, the results were far worse than expected. The glide angle reached 10 to 13 degrees instead of the calculated 3 degrees. Moreover, several serious control issues appeared. One of them was the low efficiency, and sometimes even reversed action, of the forward elevator. It turned out that this was caused by the abnormal rearward movement of the center of pressure of the highly curved airfoil at small angles of attack. This defect was later eliminated by reducing the camber. Another puzzling phenomenon was the strange reaction of the glider to wing warping. In August 1901, Wilbur Wright wrote to Octave Chanute, "Our machine under no circumstances turns toward the lowered wing. This is a very unexpected result that destroys all our theories on how to make turns." Here, the Wright brothers encountered for the first time a well-known effect, the adverse yaw moment produced when the ailerons are deflected or the wing is warped. The explanation is simple. At the wingtip with the greater angle of attack, an additional air resistance arises, which tries to turn the aircraft in the opposite, undesired direction. During the trials of 1901, the Wright brothers, taking turns piloting their glider, made several hundred flights. The longest gliding distance reached 387 feet. However, the inventors were still far from final success. Despite all their efforts to improve the gliding qualities and controllability, the flying machine of 1901 had no noticeable advantages over the earlier gliders with movable balancing surfaces. The first truly successful glider was created by the Wright brothers in 1902. Before building it, they conducted intensive research into the shapes and profiles of wings using their own wind tunnel. This allowed them to make a series of improvements that increased the aerodynamic efficiency of the new flying machine. The most important change was the use of wings with a much greater aspect ratio, 6.4 instead of 3, as on the gliders of 1900 and 1901, along with a new wing profile. As a result, aerodynamic efficiency increased by about 1.5 times. Significant progress was also made in refining the lateral control system. After realizing that controlling the direction of flight solely by warping the wings was impossible, the Wright brothers installed a vertical tail surface behind the wing. At first it was fixed and consisted of 2 planes placed parallel to each other. However, it soon became clear that this measure did not eliminate the undesirable yawing moment caused by wing warping. The raised wing still resisted turning, the roll increased, and there was a real danger of uncontrolled sliding. During one of the flights, Orville Wright even suffered a crash because of it. The solution came with the replacement of the fixed vertical stabilizer by a movable one, mechanically linked to the wing warping system, so that the rudder automatically turned in the direction of the roll. This compensated for the difference in drag between the lowered and raised wings, allowing proper coordinated turns. The Wright brothers patented this technical solution in March of 1903. With the improved control system, the Wright brothers made about 1,000 flights in 1902. Their total flight time amounted to 4 hours. The best flight covered a distance of 623 feet and lasted 22 seconds. The following year, the record flight duration increased to 70 seconds. despite its large size, a wingspan of 33 feet and a wing area of 328 square feet. The glider was reliably controllable even in strong winds. Octave Chanute, who witnessed the flights, noted the superiority of the Wright brothers' craft over all gliders built before. The next logical step was to create an actual powered airplane based on the glider. At the end of 1902, the Wright brothers shared this idea with Chanute. They wrote, "Next year, we plan to build a much larger machine, about twice as heavy as our current one. On it, we will study the problems of takeoff and control of a heavy machine, and if it proves well controllable in flight, we will install an engine." Soon after, however, they decided to build a powered airplane right away without wasting time testing a non-motorized version. When the Wright brothers decided to build an airplane, their approach to work changed significantly. Initially, they treated glider flying as a sport and gladly shared their achievements with the public. But once work began on the powered airplane, they started keeping all design details secret. The brothers understood that whoever first created a working airplane with an engine would gain fame and fortune. For that reason, they refused to discuss technical details with the American scientist and inventor Samuel Langley, who was also building an airplane. For the same reason, they did not allow the French glider pilot Ferdinand Ferber to visit their base in Kitty Hawk. The engine and propellers for the aircraft were built in Dayton during the winter and summer of 1903. The power unit was developed rather quickly because the Wright brothers, unlike other inventors, did not try to design a special ultralight motor. They ordered a conventional 4-cylinder gasoline engine with water cooling and a power output of 12 horsepower. In essence, it was a lightened version of an automobile engine weighing 198 pounds. Its specific weight was 16.5 pounds per horsepower, even higher than that of the steam engines used by Ader and Maxim. But according to the Wright brothers' calculations, this power would be sufficient to lift their aircraft into the air. The brothers believed that 8 horsepower would be enough for flight. In reality, that would have been too little, and only a stroke of luck, the engine's actual power turned out to be greater than expected, provided the necessary energy for takeoff. When creating the propellers, the brothers drew on their aerodynamic experiments conducted in the wind tunnel during the winter of 1901 to 1902. They treated the propeller as a rotating wing and selected the best airfoil for each section. As a result, they managed to produce a propeller with an excellent efficiency for its time, 66%. The propellers were connected to the engine through a chain transmission that reduced the propeller's revolutions by a factor of 3. The total weight of the propellers and transmission was 90 pounds. The aircraft was designed following the pattern of their 1902 glider, but because of the increased weight, the wing dimensions had to be enlarged. The control surfaces were also expanded. Single rudders were replaced with double ones. As on the glider, the rudder automatically deflected when the wings were warped. Skids were installed beneath the wings for landing on sandy ground. The final assembly of the aircraft took place in the autumn of 1903, after the brothers arrived at the testing site in Kitty Hawk. The airplane was a biplane with 2 pusher propellers rotating in opposite directions. The engine was mounted on the lower wing beside the pilot. As with previous machines, the pilot lay prone during flight and controlled wing warping by shifting his hips side to side. In front of him were 2 levers, one for controlling the elevator and the other for turning the engine on and off. The takeoff weight was 750 pounds, the wing area 510 square feet, the wingspan 40.4 feet, the fuselage length 21 feet, and the propeller diameter 8.5 feet. During ground tests, the propeller shafts were found to be insufficiently strong. Fixing the defect took considerable time, and meanwhile winter arrived, bringing cold weather and storms with strong winds. Yet the Wright brothers decided not to postpone the final flight test for another year. The Wright brothers' airplane had become too heavy to use the old takeoff method. Previously, local volunteers helped the craft lift off by supporting it under the wings. But now that was impossible. Moreover, such a method could raise doubts. Did the aircraft truly take off under its own power? Therefore, the brothers decided that their machine would take off independently, without any outside assistance. For acceleration, they used a wooden rail about 60 feet long, topped with an iron strip. The aircraft would roll along this rail on a small trolley that detached after takeoff. To shorten the takeoff run, they planned to launch strictly against the wind. The brothers named their aircraft Flyer. The first test took place on December 14th. The wind was weak, and to shorten the takeoff distance, the rail was placed on the slope of a sandhill at an angle of 9 degrees. After a run of about 50 feet downhill with the engine running, the airplane lifted into the air. But moments later, it abruptly pitched up and crashed onto its wing from a height of approximately 16 feet into the soft sand. The structural damage was minor, and the pilot, Wilbur Wright, was unharmed. According to the stopwatch, the aircraft was airborne for only 3.5 seconds. The accident occurred due to an overly sharp deflection of the elevator. As was soon discovered, it had been improperly balanced. On December 17th, the aircraft underwent repeated tests. That day, the wind was rather strong, and the takeoff was performed from a horizontally laid rail. Here is an excerpt from Orville Wright's diary describing the flights. After warming up the engine for several minutes to make sure it ran steadily, I began the first trial at 10:35. According to our instrument, the wind speed at that moment was a little over 20 miles per hour, while the government instrument at Kitty Hawk showed 27 miles per hour. Once released from the restraining rope, the machine started forward with increasing speed, reaching about 7 to 8 miles per hour. The aircraft lifted off the carriage as soon as it reached the fourth rail. Mr. Daniels took a photograph immediately after the machine left the ground. I found it very difficult to control the front rudder because its center of gravity was positioned too close to the main axis, which made it tend to turn on its own during takeoff and deviate too sharply to one side or the other. As a result, the machine suddenly rose to about 10 feet, and then, when the rudder deflected, it plunged sharply back toward the ground. The flight ended there, having covered roughly 100 feet from the end of the rail. Its duration was about 12 seconds. The exact figure is unknown since the stopwatch was not stopped in time. The engine control lever broke, and the strut located beneath the elevator cracked. After repairs at 11:20, Will made the second attempt. The trajectory, like mine, was wavy, up and down, but the distance was greater, though the duration remained the same. The distance was not measured, but it can be roughly estimated at 175 feet. The wind speed was not as high. With the help of the station workers who were present, we lifted the machine and carried it back to the starting rail. Around 11:40, I conducted the third test. When I had flown the same distance as Will, a strong gust of wind struck from the left, lifting the left wing, and the tilted airplane noticeably turned to the right. I immediately adjusted the rudder to descend and then applied lateral control. Quite unexpectedly, the machine touched the ground with its left wing. This shows that the effectiveness of lateral control on the new machine is far greater than on previous aircraft. At the moment it happened, the machine was about 12 to 14 feet above the ground. Just after noon, Will made the fourth and final flight. The machine continued to make small jumps up and down as before, but by the time it had flown 300 to 400 feet, Will felt that it handled much better and moved remarkably smoothly. This continued until the aircraft reached a small hill about 800 feet from the starting point. At that moment, it began pitching again and suddenly dove toward the ground. The front rudder frame was badly damaged, but the main wing structure remained completely intact. The distance covered over the ground, 852 feet, was achieved in 59 seconds. Shortly after the aircraft had been carried back to its starting position for the fourth time, a strong gust of wind caught it and overturned it. A wing was broken, and the transmission was severely damaged. Because of the bad weather, the Wright brothers decided not to repair the aircraft and returned to Dayton. The tests conducted on December 17, 1903, became the first powered flights in the history of aviation. True, earlier attempts by Ader in France, Maxime in England, and Giotto in Germany managed to perform short hops, but those were merely uncontrolled jumps through the air for a few dozen meters, each ending in a crash. The Wright brothers' aircraft, however, rose into the air several times in a single day and was controllable in flight. It was the first heavier-than-air flying machine capable of sustained, stable flight. The success of the Wright brothers was built upon their correct approach to designing an airplane. As early as 1898, the renowned scientist Nikolai Yegorovich Zhukovsky wrote, "It is far simpler to add an engine to a well-tested glider than to immediately attempt to fly a machine that has never carried a person." That was precisely the path the Wright brothers took. Step by step, they perfected their flying machine. First a pilotless model, then a glider, and finally, a fully functional airplane. They combined in themselves the talents of scientists, engineers, mechanics, and test pilots. After their first flight on December 17, 1903, The Wright brothers spent the next 2 years away from prying eyes improving their aircraft. They installed a more powerful engine, refined the control system, and added a larger fuel tank. To make takeoff easier, the designers used a catapult, a weight dropped from a tower, accelerating the plane by means of a cable. The duration of their flights increased, and the Wrights learned to fly not only straight ahead but also to make turns in the air. Now they only needed to sell their invention profitably. In the spring of 1906, in a letter to the Russian Minister of War, the Wright brothers wrote, "After many years of experiments and scientific research, we have created a flying machine heavier than air, suitable for military purposes, which we offer for sale to the governments of various countries. We propose, first, to provide a flying apparatus capable of carrying a man through the air at a speed of more than 30 miles per hour with fuel sufficient for a flight of over 100 miles. Second, to train a representative of your country to operate the apparatus. Third, to deliver to a specialist appointed by your government our experimental and scientific data, ensuring the success and further development of your aviation. Fourth, to provide formulas necessary for designing flying machines of any size and speed." The Wright brothers also stated that although they did not intend to transfer exclusive rights to their invention, they were willing to refrain from selling the airplane to other countries for a certain period if Russia were the first to sign a contract with them. Before receiving any payment, the Wrights promised to demonstrate their machine's flights to representatives of the Russian government. When this letter was received, Russian officials, still shaken by the recent defeat of their army in the war with Japan, were actively considering the use of flying machines for the army and navy. However, the focus was on balloons and airships, since all previous attempts to build an airplane had ended in failure. Nothing was known in Russia about the Wright brothers. It was therefore unsurprising that their letter received no response. The situation changed in 1908, when the Wrights once again improved their airplane. Thanks to a new engine, it could now lift 2 people, with both the pilot and passenger sitting upright instead of lying on the wing as before. Wilbur Wright triumphantly demonstrated the machine in France, breaking all existing aviation records. The aircraft stood out from early European models with its speed and maneuverability, and could fly not only in calm weather but also in strong winds. Among those who observed the flights were Russian military representatives. That same year, 1908, the Russian War Ministry decided to begin developing military aviation. Alongside the construction of domestic aircraft, it was resolved to purchase 2 foreign machines, including one from the Wright brothers. In February 1909, 15,000 rubles were transferred to the French firm Ariel, which had begun serial production of Wright airplanes. The manufacturers guaranteed that the plane would carry 2 people and have enough fuel for a 3-hour flight at a speed of 34 miles per hour. But Russia never received that airplane. In 1909, during a test flight, it crashed. The French pilot Lefebvre was killed. The accident occurred before the eyes of a Russian officer who had been sent to France to receive the aircraft and learn to fly it. To make amends, Orville Wright ordered the Ariel Company to build and send 2 new airplanes to St. Petersburg. After the crash, rumors began to spread about the unreliability of the Wrights' design. And although the War Ministry did not cancel its order, the All-Russian Aero Club, which had also planned to purchase the American aircraft, decided to postpone signing the contract. The continuation of the Wright brothers' story in Russia is linked to the name of Nikolai Yevgrafovich Popov, a man with a most unusual biography. An agronomist by education, Popov turned to journalism and during the Russo-Japanese War served as a war correspondent in Manchuria. During one of the battles, a bullet pierced straight through his chest, but he survived and in 1907 went abroad in search of fortune. He managed to join the crew of the American airship America, which was heading toward the North Pole. Shortly after taking off from the island of Spitsbergen, the airship crashed, and the crew was rescued by Norwegian sailors. After that, Popov settled in Paris, where he became passionately fascinated with aviation. Largely self-taught, he learned to fly a Wright, and during an aviation competition in Cannes in the spring of 1910, he proved himself to be a skillful and fearless pilot, earning the highest number of points and a special prize for altitude. Soon after, Popov was invited to take part in the Aviation Week in St. Petersburg. In addition to participating in these first air competitions in Russia, he had a mission from the Ariel Company to deliver the Wright aircraft to the War Ministry and to train Russian pilots to fly them. In April of 1910, Popov arrived in St. Petersburg with 2 Wright aircraft. Aviation Week took place at the Kolomyashsky Hippodrome from the 25th of April to the 2nd of May. Thousands of residents of the capital came to witness a spectacle never before seen in Russia. In addition to the Wright, the demonstration flights included French aircraft, the Farman, the Voisin, the Blériot, and the Antoinette. Popov's flights, he being the only Russian aviator, were the most impressive. A correspondent for the magazine Aeronautical Library described his impressions from the first day of the event. Popov, after the necessary preparations, swiftly glides along his rail and confidently lifts into the air at its end. At that moment, both orchestras play God Save the Tsar, and the crowd removes their hats. Popov boldly flies past the stand, makes one circle, then another, and with each lap rises higher and higher above the ground. The aviator's skillful control and the beauty of the Wright's flight, compared with the clumsy Farman's, cause a growing hum of approval among the spectators, increasing as the flight continues. Popov made 14 circles, remaining in the air for 25.5 minutes. Upon landing, he received a rousing ovation, joined by many distinguished officials from the administration. Despite damaging both Wright aircraft during the competition due to poorly executed turns, Popov still ranked among the winners and again won the prize for the highest altitude. Immediately after the end of Aviation Week, Popov arrived at the Gatchina airfield, where a new Wright intended for the training of military pilots had already been delivered. Popov was to test the machine and begin flight instruction. On the 21st of May, the aircraft's first flight took place. Seated at the controls, Popov took off successfully and circled in the air for about a quarter of an hour. Having ensured that the machine was in working order, he prepared to land when suddenly the engine stopped. He had to make an emergency landing on uneven ground. The plane struck a mound and overturned. On impact, the engine crushed the pilot. Unconscious, he was taken to the hospital. Popov suffered terrible injuries, a concussion, a broken nose, and fractures of both an arm and a leg. He survived but became disabled and could never fly again. He went abroad for treatment and never returned to Russia. Popov was succeeded by the French pilot Goubert, who arrived to train Russian aviators, but by that time enthusiasm for the American aircraft had noticeably waned. The reason lay not only in Popov's tragic accident, but also in the fact that the Wright proved poorly suited for training. Due to the aircraft's instability, controlling it was extremely difficult. In the Aeronautical Bulletin of August 1910, it was written, "These aircraft are now becoming less and less common. On one hand, due to the primitive design of their engines, and on the other because of the inconvenience of the machines themselves. Specifically, the controls require both hands of the aviator, and because of the awkward tail design, having too small a horizontal stabilizer surface and too short a distance from the main lifting planes, automatic stability is very weak. This forces the pilot to be constantly alert and makes flying extremely tiring. Only in the hands of a very experienced and skillful pilot, such as Mr. Goubert, by the way, does the flight path of this machine remain more or less level. Usually, however, the aircraft draws a wavy line in the air, resembling a boat diving over the waves. In addition, due to the low engine power, only 30 horsepower, the airplane could not fly with a passenger, even though that was a mandatory condition of the contract. All of this led the military to refuse acceptance of the Wright model tested by Goubert, and to decide not to purchase more of these aircraft. Apart from the state-owned Wright machines, there was also one such airplane in Russia, purchased with private funds. It was acquired by Theodore Kalep, the director of the motor factory in Riga. Kalep was among the first in Russia to decide to establish production of airplanes and engines for them, and the Wright was to serve as a prototype for the first batch of domestically built machines. This time, the airplane was purchased in Berlin from the Flugmaschinen Wright Company. The machine was delivered to Riga on the 2nd of March, 1910. For flight demonstrations, the pilot O. Arntzen was invited from abroad. Public trials took place on the 30th of May at the Riga racetrack. They ended in complete failure. Out of 7 attempts, Arntzen managed to lift off only once, but the flight ended in an accident. During a turn, the interplane strut with the attached fuel tank broke. It happened very close to the ground, so the pilot remained unharmed. A month later, Arntzen tried again, and once more without success. Despite this, Kalep did not lose faith in his idea. Having realized the necessity of building aviation engines for domestically produced flying machines, he wrote in one document, "The factory in Riga Sassenhof, founded in 1889, began in 1910 the construction of an aircraft engine of the automobile type. The first engine, producing 35 horsepower and equipped with water cooling, was installed on a Wright machine, and numerous flights were carried out with it. The engine built in Riga was a modified version of the Wright engine, and thanks to many improvements, produced 1/3 more power. A Wright-type airplane was also built at the motor factory. To simplify piloting, Caleb equipped the aircraft with a small horizontal stabilizer, and in addition to skids under the wings, installed a wheeled undercarriage. On the 11th of January 1911, the Riga pilot M. Trautmann made a flight in this improved Wright from the factory airfield. After covering several miles, he landed safely on the outskirts of Riga. Soon after, Caleb began producing engines and airplanes of other types, as after Popov's tragedy and the difficulties of training pilots on the Wright machines, this aircraft lost its former popularity. Also known is the selfless attempt of Stepan Vasilyevich Grizodubov, a graduate of the Kharkov Technical Locomotive Engineering School, to hand-build a replica of the Wright brothers' airplane. Having seen footage of their flights in France, he was so impressed that he persuaded the cinema operator to cut out a few frames for him. Using those, he created blueprints and in 1910, in the courtyard of his home, built both the airplane and its engine. However, the machine turned out too heavy and could not take off. In 1912, visitors to a technical exhibition in St. Petersburg were able to see an unusual exhibit, the Wright brothers' airplane, on which the Frenchman Charles D'Alembert had been the first to fly around the Eiffel Tower 3 years earlier. D'Alembert, a member of the Russian Aero Club, had donated his historic airplane to the organization. Unfortunately, it was presented in poor condition. As a correspondent of the magazine Aero wrote, "Visitors were outraged by the barbaric treatment of this relic of aviation. The airplane was not assembled, all its separate parts were simply thrown onto the stand, torn wings leaned against the posts on the side, and that was it. Or perhaps the organizers believed it was sufficient merely to replace the pilot's seats with ordinary chairs that had broken legs. Too little care was shown for such a historic machine. Abroad, such an aircraft would have been placed at the center of the exhibition and made its main attraction, while here it was turned into a pile of junk. It is painful to see such a sacred relic, to think of the brave aviator who donated his historic machine into unskilled hands." As already mentioned, the initial enthusiasm for the Wright airplane in Russia quickly gave way to skepticism. Attention shifted toward more reliable and stable French aircraft. But the story of the Wright airplanes in Russia did not end there. A new surge of interest appeared in the autumn of 1912, after Vsevolod Mikhailovich Abramovich's flight from Berlin to St. Petersburg on a Wright airplane. Vsevolod Mikhailovich Abramovich, a native of Odessa, was the chief pilot of the company that produced Wright airplanes in Germany. He became famous for his record-breaking flights during aviation competitions in Berlin in May of 1912. His flight to St. Petersburg, made primarily for promotional purposes, was also a remarkable achievement for its time. Its distance exceeded 930 miles. It should be said that the airplane Abramovich flew to Russia was quite different from the classic Wright model. On Abramovich's initiative, the front elevator was removed, the tail boom was lengthened, and a horizontal stabilizer with an elevator was installed behind the rudder. The control system was also modified. Skis were replaced with a wheeled undercarriage, and a new, powerful German engine was installed. The airplane became more stable, and takeoff no longer required a catapult, wooden rail, or detachable trolley, as on the first Wright models. The modified machine was named the Abramovich Wright. In Russia, Vsevolod Mikhailovich Abramovich took part in the second military aircraft competition held at the Corps Airfield in St. Petersburg. The Abramovich Wright was not an official contestant, but flew frequently and successfully. In one of his flights, a world record was set. Carrying 4 passengers, Abramovich remained in the air for 48 minutes. This exceeded the previous endurance record for a flight with 4 passengers, held by the German pilot Reitzel, by 27 minutes. Having demonstrated the flight capabilities of his modified Wright airplane, Abramovich sent a letter to the Minister of War, Vladimir Alexandrovich Sukhomlinov. I take the liberty of addressing Your Excellency with the most humble request to graciously permit me to enter into the Ministry of War under your authority with a proposal to supply the required number of Wright-type flying machines. Firmly believing that my aircraft will faithfully serve the Homeland's Army when the time comes, I intend also to train an appropriate cadre of military pilots. Taking into account that Abramovich's improvements significantly enhanced the Wright aircraft's flight performance, the military decided to accept the proposal. With the permission of Nicholas II, in November of 1912, the company Flugmaschinen Wright was issued a check for 114,000 rubles to purchase 6 combat and 2 training aircraft, along with spare parts for them. It was agreed that the Abramovich Wright combat aircraft had to lift no less than 573 pounds of payload, reach a speed of at least 50 miles per hour, and climb to a height of 984 feet in no more than 12 minutes. To receive the planes and train for flight operations, 3 officers were sent to Berlin: Staff Captain Gotowski, Lieutenant Mushnik, and Sub-Lieutenant Knoch. By the summer of 1913, the ordered planes had been built, packed in crates, and shipped to Gatchina. Meanwhile, Gotowski, Mushnik, and Knoch were training to fly the Wrights at the Johannisthal airfield near Berlin. There were, however, a few incidents. On April 5th, during takeoff, Gotowski's engine stalled, and during the forced landing, the novice aviator broke the landing gear and damaged the lower wing. 2 weeks later, Knoch hit some wires, crashed, and destroyed the aircraft, but fortunately he was not injured. It had been planned that once the aircraft were completed, Abramovich would travel to St. Petersburg to train new Russian pilots. But that was not meant to happen. On April 24, 1913, the talented pilot and inventor was killed. The tragedy occurred due to an error made by Princess Shakovskaya, whom he was instructing in flying a Wright aircraft at Johannisthal. The further fate of the Abramovich Wright aircraft purchased in Germany remains unknown. Most likely they were never used during the First World War. Because of frequent accidents and the complex design, airplanes of that era rarely served for long. The Wright brothers' machine was a biplane of the canard type, with a double forward stabilizer that also acted as an elevator, and 2 fully pivoting rudders mounted at the rear. The profile of the upper and lower wings of the biplane box was thin, convex-concave, shaped by closely spaced ribs. The wings had 2 spars, with the front spar also serving as the wing's leading edge. The trailing edge was made of steel wire clamped between the tails of the ribs. The wings were covered with thin, unpainted, and unbleached muslin. The rudders and stabilizers were covered with the same fabric, though only on one side. Control of the biplane's yaw and roll was achieved by warping the wings in coordination with the movement of the rudders. Interestingly, the Wright brothers designed the control linkage to operate through side-to-side movement of the cradle in which the pilot lay. The airplane's engine was a 4-stroke unit with a maximum takeoff power of 16 horsepower and a nominal flight power of 12 horsepower. In 1902, no workshop was willing to make an engine that weighed only 176 pounds. The Wrights eventually solved this challenge themselves, building the motor in their own workshop. The aircraft had 2 counter-rotating propellers driven by a chain transmission. The propellers were wooden with a thin concave convex profile. Their shape and dimensions were determined through numerous experiments. The airplane had no wheeled landing gear. For takeoff, the designers built a launch catapult consisting of a pyramidal tower and a wooden guide rail. The catapult was powered by a heavy falling weight connected to the airplane by a cable and pulley system.